Welcome to this webinar on API 60 ball valves. I will be covering the Trunnion-mounted range of ball valves. My name is NR Venkatesh. Now I will just get into the technical presentation on these ball valves. API 60 ball valves in general will cover a wide variety of pressure classes, right from class 150 to class 2500 and various sizes right from 2 inches to up to 60 inches. And they find critical process requirements in hydrocarbon, power, chemicals, fertilizer industries. It is available and actually manufactured in a wide range of materials: carbon steel, stainless steels, alloy steels, duplex stainless steels, and so on, with various seating options depending on the process requirements and working parameters like temperature, compatibility of the media, and also other parameters. As I mentioned, these find major uses in the oil and gas industry, primarily in pipelines, offshore and onshore drilling, refineries, petrochemicals, terminal storage, manifolds and metering stations, and many other process line applications. By definition, a Trunnion-mounted ball valve has a ball which is actually held in a fixed axial position. So it is done with the means of a Trunnion-mounted design. The upstream and downstream seats are spring-loaded, and seat rings are allowed to float. So it is a sort of a floating seat ring concept, which actually helps in ensuring proper sealing through loading of the line pressure also. These valves are upstream seated valves. I go through the design standards quickly. Valve design is as per API 60. It also meets the valid clauses of ASME B 16.34. The face-to-face dimensions are as covered in API 60 standard, which you are aware. This standard is American Petroleum Institute standard for valves for both pipelines as well as piping. Wall thickness is given as per ASME B 16.34. The flange and butt weld end dimensions are the same dimensions as given for the piping. That is, the flange dimensions could be as per ASME B 16.5 or 16.47, depending on the valve sizes. ASME B 16.25 indicates the butt weld end dimensions. And there are various other standards to which these valves meet, like the pressure testing as per API 60. The fire test standards are as per the reputed API 607, 6FA of the ISO standards. And the valves often are asked to meet the fugitive emission test requirements of ISO 15848. Could be the class A or class B requirements. If we go to the various variants that are prominent in this type of valve, the bore, in terms of bore, it could be a full bore or a reduced bore. Body construction, we can often see these valves in a two-piece design or a three-piece body design. And another variant is the top entry design. And we will show you pictures of each of these. In terms of the joint, body joint, which is actually seen in a side entry valve, it could be a bolted valve or a welded valve. And it comes in various seat design configurations, with a soft seat or a metal seat or a hybrid of a primary metal seat with a secondary soft seal. The various materials of construction which are encountered in such valves are the body and connector in various metallurgies like carbon or low carbon steels, stainless steels, duplex stainless steels, super duplex. We have a lot of inconel valves, which are generally for the applications of sow gas and medium containing hydrogen sulfide. That could be Hest alloy materials and valves with cladded body. And the internals like ball, seat ring, stem are also made out of the similar materials, as I mentioned for the body and the connector. When I meant the connector is the other piece of the body in a two-piece or a three-piece body design. Whenever the ball or seat ring is made out of carbon or low carbon steels, it typically comes with a coating like a electroless nickel plating. There being soft-seated requirements on these valves also come with typical plastic and elastomeric materials. We will show you where these materials come up. The thermoplastic materials are normally in either nylon, Devlon, reinforced PTFE, or PEEK. Common elastomeric seal materials are in Viton, nitrile rubber. There could be certain chemical applications coming with EPDM. And there are other parafloor elastomers like Calres, which are also used as elastomer seal materials in these valves. The other variant is the metal seated range of valves. If I really look at the construction of a two-piece body design and the trunnion-mounted concept, if you see, the ball has two cylindrical protrusions at the top and the bottom, which are called the trunnions, and those are housed in components called the bearing holder or the bearing blocks. And along with these bearing blocks and the ball, these are housed tightly between the two pieces of the body, or it could be three pieces, as I will show in the forthcoming slides. There, since the ball is rigidly held between along the stem axis, that is done by means of the trunnion, and that is why it is called as a trunnion-mounted ball valve. And to ensure some flexibility for sealing, the seat is spring loaded, and I will show you the arrangement of the seat assemblies in the forthcoming slides. These valves could be either with flanged ends or butt weld ends, and the typical stem drive is on the ball. The stem drives the ball through a quarter turn. So this is basically a quarter turn valve, which by means of that quarter turn, the valve could be moved from a fully open to a fully closed condition, or vice versa. There are various seat options, as I mentioned. And the stem design, it is basically provided, the valve body is also provided with a cover flange over which any sort of actuation can be mounted. If we really look at the space just outside the ball and inside the body, it is where the cavity of a ball valve is, because it is held between two seats. And these cavities can be actually accessed by means of either a drain or a vent, which has provided, which will provide the access to the cavity. I go to the next slide, which is a three-piece body. Typically, the internal constructions being similar, the body in place of two pieces, it will be in three pieces. And this particular design with a cylindrical centerpiece and similar cylindrical pieces of the two end pieces, they call the connector. These are more amenable for forging. So this three-piece body design, you could actually see that it is a design which is more used with the forged construction. The valves will also come with support lugs wherever required on the larger sizes. The other design is the top entry design, where the body is a single piece and the ball and seat rings need to be assembled from the top. That means basically the ball and seat ring design is ball and seat are assembled from the top, and the entire thing is covered by means of a cover. And this particular construction is similar in construction to a body bonnet joint of a conventional gate valve. So if you really see that, these ball and seat rings need to be assembled from the top, and hence the name of top entry. The valves also come with different types of joint design. It could be a bolted joint design or a welded body. And if we really look at the construction of the welded body, this will not allow any other access to the atmosphere from the inside. So typically what is understood is these are basically used for buried service and buried service applications. And when these are used for buried service, these valves are actually provided with stem extension, so that the stem and the operator could be accessed at a convenient level from the ground. Coming to the various seat options, we have the soft seated design, where this soft seat in thermoplastic material makes contact with the ball. This is housed inside a stem housing. This is a metallic stem housing, which in turn is loaded by means of helical springs, multiple helical springs, which are provided at the back of the stem housing. When we see that this is a metallic stem housing and there is a sealing required between the stem housing and the body, it is provided by means of elastomer O-rings. So this is the construction of a soft-seated design. We also have a design of a primary metal seat, where there is actually a simultaneous contact of the metal and the soft seats. And these are typically used in pipeline industries for a longer durability of the valve. So the other major variants are the metal seated conditions, metal seated varieties. So one of the options is metal seated with a O-ring at the back, which will be used for temperatures with a certain limit, for example, 270 degrees centigrade. And the other thing is for high temperature valves, because elastomers will not function at that temperature, we need to look at an alternate of a graphite seal material. And typically, the metal seated valves come with a hard facing on the ball and seat rings, with a tungsten carbide or a chromium carbide or a stellite coated ball and seats. So coming to the back side design, that is the seat housing or the O-ring back side of the body, the sealing is by means of O-rings, elastomer O-rings for the normal temperatures, whereas the alternate is when we go down or go up the high temperature, in place of the elastomer, the option of a graphite seal is provided. And when it comes down to the lower temperatures, especially for low temperature and cryogenic, or for chemical applications where elastomers are not compatible, the option is to go for a lip seal design. This is basically a thermoplastic seat with a spring energization. So if you look at the typical features, these are many of them as required in the standard API 60. The valves are provided with an anti-static feature, because these valves being, whenever they are soft seated, there could be a electrostatic charges getting developed, and that the design should ensure that there is an electrical continuity between the seat, ball, stem and the body. And that is by means of a ball and plunger arrangement, which will provide the anti-static feature. The stem sealing is, I will explain in the forthcoming slide. There is a blowout proof stem that is provided so that the stem doesn't get ejected from the valve. And there are other features like the drain and vent, which I mentioned, which will provide access to the cavity. The seats and the stem are also provided with a feature for sealant injection. This is primarily to take care of the aspect that after prolonged usage, if there is any minor passing on the observed from the valve, there could be a means of actually charging in the sealant, which will actually flow through this passage onto the interface between the ball and the seats, which will provide some temporary sealing, which will take care of the valve till the valves are taken up for maintenance. Larger sizes are provided with foot supports and lifting lugs as per specifications. If you come to the stem sealing, the primary sealing is by means of an elastomer O-ring, which I mentioned earlier. It could be in white on or any other specific materials or the FKM materials. There is a second level of sealing called with the graphite seals, which will ensure that it is not only acting as a secondary level, it will also ensure the fire safety of the valves. And all these valves are actually tested to the requirements of ISO 15848. And we are also complying to the requirements of API 641 and have tested the valves to these standards also. The body sealing between the two pieces of the body, the primary seal is by means of an O-ring, and the secondary seal again by means of a graphite seal, which acts as both as a secondary seal as well as a protection for the fire safety. This is the other inbuilt feature on this particular set of valves, the double block and bleed feature, which will, as the valves are upstream seated and spring loaded, the fluid on either side of the valve will be sealed on the individual sides. So that is why it is called as a double block. And the cavity could still be accessed by means of the drain or vent. So it provides the double block and bleed feature. The added thing is, even in the valve fully open condition, there will be no passage of the media from the bore to the cavity. So that it can be checked online, so that you can actually see it enables online affirmation of the proper seat sealing. So in the closed condition, the valve cavity can be evacuated by the vent and drain connection also. The valves are fire safe and fire safe tested to various with the different types of seat designs and the different body constructions. We have tested all the two-piece designs, a three-piece design, and the top entry ball valves. And primarily the conformance is to the American Petroleum Institute standards like API 6FA and API 607. These valves come as a standard with the self-relieving seats. That means the API 60 standard says the body cavity pressure should not be allowed to exceed 1.33 times the design pressure. And that is ensured in such a way that when the load due to the pressure in the cavity exceeds the spring load, it actually pushes the seat rig back and relieves the pressure. So it ensures that there is no high pressure buildup in the cavity, which could be a potential safety hazard. The other option in this particular seat design is a double piston effect, where in place of cavity relief sort of construction, which I mentioned in the previous slide, the seat ring geometry is provided in such a way that the resultant force on the seat ring is always towards the ball, and that ensures that for the medium on the upstream, it provides the piston effect on the upstream side, and the pressure from the cavity provides the piston effect on the downstream side. So it is classified as a double piston effect. In other words, it is also called as a double isolation and bleed as per API 60. In the case of top entry ball valves, if you really look at it, as against the side entry valves where the joint bolting is in line with the pipeline, here it is away from the pipeline. So this is a different sort of construction as in the case of a conventional gate valve or a globe valve. So you have a body and cover joint which is away from the pipeline. These seat designs need to be retractable for assembly purpose, and this will require special tools and tackles to assemble and dismantle the components. When we look at the higher pressures and higher sizes, these could be compact in a similar way as in the side entry designs also. The valves with special designs can also be provided with the inconel overlay on wetted parts of the body and the connector. These primarily go in for applications involving the presence of hydrogen sulfide or source service applications, where these special requirements can be taken up for any size and pressure rating. The body connector are provided with this overlaid inconel 625 material, and in addition to that, the internals like ball could also be provided with this overlay, whereas the other smaller components would be provided in the corrosion resistant material itself. I will just go through some of the pictures of these ball valves. It is an emergency shut-off valve, where these valves are actually provided with pneumatic fail-safe spring return actuators. So depending on the, although I have classified it as a shut-off valve here, it could also be a blow-down valve depending on the configuration of the actuator selected. So that it could be for fast closing and emergency applications. So these are primarily the shutdown and blowdown applications. Some glimpses of the large size valves which L&D Valves has manufactured and with higher pressure rating are the high pressure class 2500 valves. We have made a 48-inch, and very recently we have supplied a 56-inch class 150 for a gas gathering station in Kuwait Oil Corporation project. There are high pressure valves which we have supplied both to the offshore platforms as also to other gas applications in Aramco. And these are some glimpses of that. We also have a large range of class 2500 ball valves, and all these valves, depending on the requirement for specific applications, have been tested with gas, with all gas testing requirements. And these have been primarily supplied for the gas handling, Shaiba gas handling project of Saudi Aramco. This is the typical example of a valve with stem extension, which I mentioned, valves with welded body design. If you can see the picture, the welded body design is on the valve, but these valves are also provided with puck pieces so that the welding of the valves with the pipeline is at a quite a larger distance from the seat area. And if you look at this, the stem extension which is provided, it ensures that if the valve is buried up to a certain height, the stem and the actuator operator will be available at a convenient level from the ground level. So typically distance up to this would be actually buried under the ground, and the person standing on the ground level could be able to access the actuators and other related components. Also, the auxiliary lines like the drain, vent, seat sealant lines and the stem sealant lines are brought to the top at a convenient level for easy accessibility above the ground. Some examples of actuated valves. I mentioned the valve is amenable for as an actuation. It could be not only a manually operated valve with a gearbox, it could be fitted with hydraulic actuators, electric actuators with a gearbox, or with gas oil actuators. And these are typically some glimpses of the supplies we have made. Some more examples of the valves with the gas oil actuators, and even if you could look at it, these valves are provided with welded joint and with puck pieces. Some more glimpses of these actuated valves. These could be pneumatic, hydraulic, again, gas over oil actuators. And typically I mentioned the spring energized clip seals for low temperature. And when these valves are made for low temperature, these typically come with a extension bonnet so that the standard graphite packings are brought to a much higher level. And as expected by various standards or specifications, there is a extension bonnet that is actually provided for the low temperature or cryogenic applications. And the internal elastomer seals are actually replaced by the spring energized plastic lip seals. One more category of these type of valves is a twin isolation ball valve. You could imagine this, there are actually two sets of the internal components like the ball and the seat rings. and the stem drives, so that this provides a redundancy between for any specific applications. These specifically come in small size valves and are often used for offshore applications. And there could be actually a bleed valve between the two closure elements to drain the tap fluid. These Trunnion-mounted ball valves, or the API 60 ball valves, are also used as the final control elements of a HIP system, like what we call as high integrity pressure protection systems, where these valves are actually fitted with pneumatic or hydraulic actuators. And L&T valves can supply this entire system as a single skid, with the valve actuator, the pressure transmitters, and the logic solver. And this entire skid could be actually used to actually isolate a high pressure side and a low pressure side, which is the real purpose of a high integrity pressure protection systems. So I think with that, I almost conclude my presentation.